Okay, now we're recording. So here is our exponent form and our log form. And what would you call the big number at the bottom of the power here? You know what that's called? It's called a base, right? A base of your exponent when you go to log form is called the base of the log. And it's a small number written down below. It's called not superscript, subscript. If you were to actually type it into a computer, you have to change it. And if you look at all the times you see the word log, there's this little number at the bottom that's called your base. So if I'm going from log form to exponent form, I take that little number and it becomes the base of my power. Or if I'm going the other way from exponent to log, the base of my power becomes the base of my log. Make sense? The other two literally just flip order. The y and the x flip. So that my answer over here is always whatever the exponent was over here. Does that make sense? Because the whole purpose of a log is to get the exponent into a way that we can actually solve for it. So we're going to get to the point where using logs would help us to solve a problem like we discussed yesterday. Remember yesterday we had that penny doubling every day, and I asked you how long would it take to get to $3 million? And we decided that it was somewhere between 28 and 29 days, correct? Using logs, because I'm able to rewrite something to pull that exponent down into a workable place, I could actually find exactly how much it is. It's 28.23 days or something like that. That's where we're going to go with these logs. So let's start off with just the rewriting form. So I have exponential form on the left, log form on the right. When my exponential form looks like that, that is a true statement, correct? Okay. Log form, I'm going to write the word log. The base of my power is 2. That's going to become the base of the log. And it's written little and down below. And then, what do I do with the 3 and the 8? Flip them. So I have log base 2 of 8 equals 3. That's how I would rewrite that statement. Right here, by the way, she has a little sentence, because a lot of people, they'll see that and they're like, log 2, 8 is 3. And so if you want to sound intelligent when you're reading it, you say log base, whatever the base is, of whatever that number is that. So that's kind of the statement that you would say. Okay? Let's look at this one. What's different about this one, other than the fact that it's different numbers? Where's your exponent? It's on the right side of the equation as opposed to the left side. Now, sometimes that confuses people. They like to always see the exponent on the left because they get in a pattern of how to rewrite it, and it just makes life easier. If you are that kind of person, then do this. Put the equals 81 over there and forget about it and treat it just like the one we just did. Okay? That would be log base what? Base 3 of 81 equals 4. That number on the other side of the equal sign is always the exponent from the original one. Always, always. Okay? What if, let's go back and do this one now. What if I had log form and I wanted to go to exponential form? The base of the log is 4, right? Therefore, the base of my power would also be 4. What's the exponent? The exponent's what is out here, right? So 4 to the third is equal to what? 64. Is that a true statement? Yeah. If I get a false statement, then chances are I mixed up my numbers somewhere. I should get something that's true. What about this guy? What would the base of my power be?
8.
8 to the what power? Negative 2 equals 1 over 64. True statement? Yeah. Okay. How about this one? This one would be log base what? 625 of 25 equals 1/2. So you can have a large number as the base. That's not a problem. You can also have a fraction as a base, which we'll see coming up soon here too. All right, this one's in log form, so I got to write it in exponential form. What's the base? 49, right? There's my base. What's my exponent? Equals 7. True statement? Yes. 49 to the 1/2 really means the square root of 49, and yes, that's 7. All right, I want you to try the next 3. So go up to there for me. Y'all done? It's pretty quick, isn't it? Doesn't take that long to rewrite. All right, what would my base be in this one? Log base what? 3. Now this one's backwards, isn't it? So if it's messing with me, then put the equals 1 over 27 on that side and look at it this way. That helps a lot sometimes. So log base 3 of 1/27. A lot of times you'll see that in parentheses, sometimes not, but a lot of times you will. Equals what? -3. All right, how about here? What's my base? 14 to the what power? Equals 1. True statement? Yes. And this guy, this would be log base what? This one's backwards again, so I'm going to put the equals 1 on that side. Log base x of what? Equals 0. It does say if x is positive. We'll talk a little bit more about that later, but our bases always have to be positive when we're talking about logs. Okay? All right, the next 2 right here. I call these the Matchy-Matchy Rules. It was funny, Miss Armstrong came and asked me, she was going to put the name of these laws, I guess, in here, and she couldn't remember or didn't know what the name of the law was, and she said, what do you call that? You know, what's that law that has the, you know, base equal whatever? And I said, they're the Matchy-Matchy Rules. She said, I don't think that's legit. I don't know if we're going to put that in the notes. And I'm like, eh. So I call it the Matchy-Matchy Rules. So what I notice here is I have a matchy-matchy going on right there. My base is the same as the number here. Let's look at exponent form to see what's going on. Because this says it equals 1, and I want to understand that a little more. So if I had it over here, what would the base be? To the what power? Equals. That makes sense, doesn't it? So in log form, if I can recognize that I have matchy-matchy, my answer will always be 1. Because anything to the first power is itself. So if I had log base 8 of 8, the answer is 1. If I have log base 10 of 10, the answer is 1. Okay? Whenever your base and the number are the same, your answer is 1. This one is slightly different. I still have the matchy-matchy, but now that one has an exponent. Which means the answer is not 1 anymore. Guess what it is? It's whatever that exponent was. So if I have, for example, log base 8 of 8 squared, this rule is saying that my answer, since I have matchy-matchy right there, my answer is going to be 2. It's whatever that non-matching part is. Let's look at exponent form to see why. What would the base be? A, right? There's my base. My exponent is x is equal to a to the x. Make sense? Now it makes sense when I look at it that way. Okay? Whenever you look at a log, if it doesn't make sense to you, my advice is always take it and write it in exponent form. And then usually it'll make sense to you. Okay? All right, I'm going to hold off on this part right now. Let's come up here. By the way, before I get there, your homework assignment, you're going to get it and you're going to freak out because there's 36 questions on it. And that's ridiculously long, isn't it? But the first 10 questions are simply taking a logarithm and writing it in exponential form. That's a piece of cake, right? You're just flipping things around and writing the word log. The next 10 questions are taking something in exponent form and writing it as a log. So the first 20 questions of it should take you like maybe 5 to 10 minutes. Then you have a couple questions that'll take you even less time. It should take you 30 seconds to do all 4 of those. Then the back side is where things actually get a little bit more challenging. The front side should be a piece of cake. And I'll talk about the back side. That's where we get into questions like this. You ready? All right. So you had a problem similar to this on your homework last night because you had a problem that asked you to find f of 2 or f of negative 2 or whatever, where you're plugging in that value for x, correct? So if it gives me, this is my expression right here, I need to plug in what here for x? 36. So in other words, I'm trying to find log base 6 of 36. You follow so far? Now I'm going to go ahead and put equals, and instead of f of x, I'm just going to call it y just for ease. So far so good? Okay. If I don't know what to do, what did I mention just a couple minutes ago was always my advice? Change it to exponent form, because then you will most likely know what to do. So if I go to exponent form here, what's the base going to be? 6 to the what power? Equals, I should know my answer now. What is it? 2. And the reason why it's 2 is because I know that 6 to the y on that side, 36, can be written as 6 to the second. And when I have those matching bases, I know that the exponents have to be equal, and that's where my 2 comes from. From here, you could probably do that in your head. Does that make sense? Okay. Let's look at this one. Here's my expression right here. And they want me to plug in 6 for x. So I have log base 36 of 6, and I'm going to go ahead and say equals y. By the way, that writing kind of bugs me. I didn't write that very well. I did something that I always dislike doing. There are a lot of people that will write this thinking that that 6 is an exponent. Like I'm going straight from subscript to superscript. When it's not. It's regular text, subscript, regular text. Does that make sense? So I wrote that kind of weird because I don't like that that's so far up. Yes, I'm particular, but math is particular. Every little mark means something. You do one mark, it's a parentheses, and all of a sudden it changes the orders that you have to do things. Okay? That's called notation. All right, going to exponent form. What do I do? What's my base? 36 to the what power? Y equals. Okay. Let's get our bases to match. I can write them both as powers of 6. So 36 I'm going to change to 6 squared. Now it wasn't just 36 though. It was 36 to the y. So I have to keep the y there as well. Make sense? And then over here I have 6, and that would be 6 to the first power. Now that I have matching bases, what do? This has to equal that. 2y has to equal 1. So what do? Divide by 2, and y equals 1/2. this is what the backside of your homework looks like, is these kinds of problems. My suggestion is just go ahead and throw an equals x onto the problem, change it to exponent form, and hopefully from there you'll be able to get to your answer really quick. Okay, so throw an equals sign on there, change it to exponent form, and you'll be able to get there. Okay, 216 happens to be 6 to some power. I'll let you figure that out. This would be 6 to the negative 1 and go from there. I believe it's 6 to the third. So you set those equal to get to your answer. Okay, so that's what you're doing on the back side of your homework. I'm going to show you a shortcut in just a minute for some of these. Let's look at this guy. So here's my expression. Log base 1/4 of 8. And I'm going to go ahead and set it equal to y. So let's go to exponent form. What's my base going to be? 1/4. When your base is a fraction, you always put it in parentheses. What's my exponent? Y equals 8. Now I said that kind of quick. When your base is a fraction, you always put it in parentheses. Why? Just because I'm picky? No, because if you do this, that technically means that the exponent's only going to the numerator. Do you see that? When you put it like this, all of a sudden that exponent's going to the numerator and the denominator, like it should. Okay, so there is a reason for that. All right, this one's a little trickier. Why? I can't call this 4 squared equals 8, because that's not true, right? I can't do like 8 to the 1/2 and get 4. What am I going to do? How am I going to get common bases? How am I going to get to the place where I have bases matching so I can deal with the exponents? Well, I have to think of a number other than 4 or 8 that I can use as a base. Any suggestions? 2. 1/4 we know is 2 to the what power? Well, the 4 means it's 2 to the second. The fraction means it's 2 to the negative second. And I still have the y there. And 8 is 2 to the third. Now I have common bases. So occasionally you'll come across these ones where you have to just totally go to a different number completely. So my bases match, so negative 2y equals 3. Divide by negative 2. And what does y equal? Negative 3/2 is my answer. So? All right. Alternate method. Less writing, more thinking. This one is a mental math way of doing these. Okay? Do you notice that this problem right here is exactly the same as this problem right here? When you plug in 36, this is the problem. The way that you would do this is you would think to yourself, my answer is the exponent that would go on 6 to get a result of 36. So in other words, 6 to the what power equals 36? And you would say 2. Right? 6 to the second power equals 36. The exponent has to be 2. What would this one be saying? 36 to the what power equals 6? It's a square root, right? So the exponent would have to be a 1/2. Okay? Now, if I can't reason that in my head doing the mental math, by all means I can go this way and do the writing out of it. But some of these I can get to a little bit more quickly. Now, I'm going to skip this one for a minute. This one right here is very similar to this one, but a little bit different. So this is one like you would see on the back of your homework. I'm going to go ahead and set it equal to x and go to exponent form. What would it be in exponent form? 8 to the x equals 4. And that 8 and 4 again, I'm going to have to rewrite those as 2's, right? So 8 we would write as 2 to the third to the x. And then 4 I would rewrite as 2 squared. So what's my equation? To get x, 3x equals 2. Divide by 3, and x equals 2/3. Now, that one had kind of an ugly answer. 2/3 is a much more difficult fraction to recognize than 1/2 is. So sometimes when you get fractions that are a little uglier, you're going to have to do a little bit of work as opposed to just doing it in your head. Okay? All right, I'm going to come back to this guy because I need to address these two things right here. And these two things are probably the most important logarithms you're going to learn. Okay? And it always drives me nuts that they're in a tiny little corner here, and yet they're so important. And someone will come ask me a question about it, and I'm like, that's the important thing on the front page. Make sure you know what it is. There is a thing called a common log. And if I look down right here, do you see this says log 5? There's a problem with that. What's missing? The base. There's no base. So when you're given a problem like that with no base, how do you change it to exponent form? Well, you need to recognize that that's what's called a common log. And in a common log, there is no base written. You need to know that it's a base of 10. So no base written means it is a base of 10. Now this comes into the reasoning as to why, if I can find my calculator, I sometimes say, or why I'm considering regulating the calculator you're going to be able to use on your test, because my calculator, there should be a log button on your calculator. That's your logarithm. What does it say above that? 10 to the x. Do you see that? That's because a log, if I were to change it to a common log, I should say, if I were to change it to exponential form, would have a base of 10. That's why those buttons are together. Now, my calculator only calculates a common log. It will not calculate something like this because that has a base other than 10. My calculator only likes base 10. Some calculators, such as these ones, have a log button where it allows you to put in a base other than 10. So people with certain calculators have an advantage over other ones because this person can just say, oh, log base 6 of 36, I can just type this in and get my answer, whereas the person with this calculator can't. That's not really fair, is it? Which is why I'm looking at, on the test, having you not be able to use your own calculator, just being able to use the calculator that I can attach to your test on the computer. That puts everybody in the pink calculator category where you have to understand what you're actually doing. So if you have one of these calculators, make sure that even if you're doing this to check your answers, that you're understanding the process as if you didn't have that special calculator. Does that make sense? Okay. I believe if you have this calculator, your common log button is right here. Try and get in the habit of using that one because that will help you practice this as well. Okay? Don't use the one where you can actually plug in the base. All right? So, common log, as I said, that's what my calculator calculates. So if I wanted to find log of 1,000 equals 3, or if I wanted to rewrite that, what would the base be for exponential form? Base would be 10. What would the exponent be? 3 equals 1,000. So even though it looks like that, my brain needs to interpret it as log base 10 of 1,000 equals 3. You would never see it written this way, but that's what my brain needs to interpret it as. Okay? So if I'm given a problem like this, log 5, and it says evaluate with a calculator, I go straight to my calculator. I'll use this one. I'm going to use the log button, not the one where I can put in the base, but the other one. Log 5. And in general, we usually like to get 3 digits past the decimal. So this would be 0.69, and then 89 would make that 8 become a 9 also. So 0.699 as my answer there. Questions about that? Okay. All right, the other important one is known as a natural log. A natural log, it's funny, they abbreviate it LN, which I almost think it should be NL because it's natural log, but they flipped it. I can't tell you how often people will be like, oh, it's that IN button. That's not a capital I and a lowercase n, that's a lowercase l and a lowercase n. It's LN for natural log, not IN, just so you know. A natural log has a base of E. So it's going to look like this. It's still a logarithm. It's the only logarithm that doesn't have the letters LOG in it. It just has LN. But when I see this, my brain needs to think log base what? E of 10 equals X. I will never see this written as log base E, but that's what my brain needs to think. Okay? So what would that be in exponent form? What's my base? E to the what power? Equals 10. If it said to evaluate with a calculator, I go to my calculator, I go to my LN button. Notice your LN button, wherever it is, it's related to your E button. Do you see that? So it should be close to your E button. Why is it related to your E button? Because it's a log with a base of E. I would put ln of 5, and I get my 3 digits past the decimal would be 1.609. Yeah? Alright, these two are actually the same thing. It's 1.609 and 0.699. Those are the exact same as what I wrote right there. What would this be in exponential form, though? Now that I have my answers, if I wrote them in exponential form, what's the base? E to the what power? 1.609 is equal to 5. Is that true? If I went to my calculator and I put E to the 1.609, do I get 5 as the answer? 4.9978. That's not 5, but it is darn close, isn't it? Why is it not exactly 5? Because I rounded. If I didn't round, if I used that whole previous answer button thing, I would get exactly 5. Okay? What would this one be in exponential form? What would the base be? 10 to the what power? 0.699. Let's see. Does 10 to the 0.699 equal 5? Again, not exactly, but really close. Why is it so close but not exact? Because I rounded. Okay. All right, last question I want to talk about right here. Do you know the answer to that? If you had to guess. 1 over something, I heard. Is that because it's a negative exponent? Mm-hmm. You're wrong, but good thinking. I like that train of thought. This one is kind of a trick question because it's actually a matchy-matchy. Remember my 2 matchy-matchy problems up here? I need to think of this as natural log would be log base E of E to the negative 7th. Do you see the matchy-matchy? So what's my answer? Negative 7. Often, when they are using these matchy-matchy rules, they will give you a natural log, or they will give you a common log, because those are the 2 times that a base is not written, so it's not quite as obvious that it's a matchy-matchy. So always check what's that base if it's missing, to see if you can use that matchy-matchy rule and get to an answer easily. Okay? So? All right. Happy studying.